Sorry for that. All right. So this basically provide you control, provide you data, but only within your own network. And definitely for IoT, this is not yet a true definition of IoT, the Internet of Things, because we don't have yet the internet element here. This is only on the local network, the local area network. So it only work within your network. So if you have like, if you sit within your network, okay, and your device inside here, and your router is inside here, and there's another node here, your computer is here, your device is here, so it means that it only works within the same network. Okay, so no matter how many sensor that you have, microcontroller that you have, so each will be provided with IP address, and then you can communicate to each other only within this LAN. Okay, local area network within the same network. Okay, issue CUM, security of this. Okay, so they somehow block the access of IP address from one the other. And I'm not quite sure, even nowadays they also disable ping due to security. Okay, so they tighten up the security so that it is more secure for users to use the network. But this is not IoT in its full term. Okay, so because the internet is only local. Okay, so the IoT term here means that the device that you have here, the device that you have here, this is connected to the internet, IoT. So means that your router will be connected to the internet. Okay. Okay, so you need to be able to connect to the internet, and somewhere you have your server hosting data. Okay, store the data, you read the sensor data here, and then connect to the internet, connect to the Wi-Fi, and then connect to the internet, and then store the data into the database. So this is what we are looking for when we talk about IoT or any IoT project. So don't just simply give the name IoT when you use a microcontroller and sensor. If you don't have the internet element, that is not IoT. That just a simply sensor and microcontroller project. Okay, even though you're connected to local network, that still cannot be defined as IoT project. Okay, if you are talking about IoT project, this is the requirement. It has to be connected to the internet, and then somewhere over the cloud, you have your database, you have your server-side script, you have all the cloud services that you're connected to, and then your device are able to read data, store data, receive instruction from server, and also to make things more interesting. So you have like, you're in Japan, right? So you're here, and then your device also connected to the database, and then you can read the data and you can write the data, or you can give instruction either to turn off and on whatever device that you have here, thousands of kilometers away, and then you're actually connecting to the database, not to the device itself, because the device only dump the data or read the data from database. Your device here also read and write data to the database. So it basically provide this what we call it intercontinental access to the device. You are not directly accessing the device, because if you are able to do that, means that it is end-to-end connection, end-to-end connection. So end-to-end connection basically allow you to connect to the device directly without having to use any database and whatnot. Okay, but that is not possible with IPv4. That is not possible with IPv4, because IPv4, we depend on the IPv4 addressing, which is very limited, and most of the address is not that many. We talk about IP address, but in IPv6, yes, that is possible with IPv6, which allow for end-to-end connection. But IPv6, even though it has been around for for 10 years, but not much use to it yet. There's no killer application to the IPv6, hence it's not very popular even though nowadays. Okay, so I believe you've learned about or you heard about IPv6, but nowadays all the internet still run on IPv4, all the hardware still run on IPv4. There are IPv6 enabled, but everything still on IPv4. Okay, IPv6 allow you to do the end-to-end connection. The IP address is a global address, addressable global address. IPv4, no. Everything translated to NET, what do you call it? The net addresses. So everything that you have inside here is netted address, but the outside point here, this is the only global IP address that you have. So everything netted inside and protected within the network. So nobody knows what the IP address inside here unless you are inside the network. So the network here still run on IPv4. So that's what we're still working on. IPv6, not that much yet. There are works on that, there are research on that, but still lack of wide or still not that widely used in the world of IoT. Okay, or even your computer still running IPv4. So, for example, like if you go into your command prompt, you can clearly see that this is the IPv4 address. This is the IPv6 address. Okay, but the IPv6 address only accessible to a server or router that running IPv6 address. And the FE address, this is basically a local IPv6 address, but we haven't yet enabled that. Even though my last research is on IPv6, I work on IPv6, but it doesn't seem to catch up. Okay, it doesn't work well because of the cost. We need to change all the router all around the world to be able to make it to works. So not anytime soon. Okay, maybe like 10 or 20 years in the future, maybe we're going to use IPv6 address. But at the moment, we're stuck with this address, IPv4 address. Okay, so that's how the world works, and then we have to develop the system based on that architecture. All right, so any questions on this? AP mode, Wi-Fi mode, web server, which is local web server within the device itself. Okay, so we can create our web server response with our ESP, and then we can use that either for data display or control, and then you can retrieve the data or whatever that you want to do, as long as it involves input and output with your ESP. Any question on this or on what I've talked for the past 2 or 3 classes? Okay, so all the code basically I already pushed to GitHub, and then you can use that example. Okay, so now we're going to look into full-fledged IoT. But before that, EEPROM, I think I already talked about EEPROM, but EEPROM, we're not going to use this unless you want to develop a full-fledged system, which means that you are ready, your system is ready to be implemented, to be published later on, to be used in the hardware, in PCB form. So you want your system to be customized enough for user to be able to change their configuration on the fly. But this is just for your information only for now. Okay, for now. But if you want to develop a full-fledged project, you are going to need this. Okay, you need to be able to change to a different Wi-Fi configuration, and then allow for your system to be customized. But if you just want to use UM Wi-Fi guest, or you just want to use your own Wi-Fi ID, SSID, you can just hard code it into your code, and then you're just good to go. Okay, for prototype level, no issues, but for the real implementation, you need to be able to allow for user to customize your system. Okay, and EEPROM basically allow user to do that. They can change their configuration easily. But with that, you need to enable the access point mode, and then you need to allow for system to be able to read the current configuration, and then user can change to a new configuration, right? So that's what EEPROM allow you to do. You can read and then you can write the data back. So those are the scenario usually used in Wi-Fi configuration or device ID configuration. So you want to be able to change that. Okay, you want to be able to change that. So this is the example that I provided to be able to change your password and SSID. As you can see here, we provided the SSID for the access point mode, and then create the access point mode, and then user can enter the access point through 192.4.1. So access that, and then we provide this simple form here. This is just a very simple form which allow user to enter new SSID and password through the input section here, and then press the submit button. So once user press the submit button on this root, they should be able to save the data setting, get the SSID from the form, SSID and password, pass the data to the write data function, which is the write data function at the bottom down here. This would allow for the new SSID and password to be written into EEPROM. So once completed, so we just exit. I believe there's an exit there. Or this one just success. And then please reboot to take effect, because when you press reset, it basically go back to your setup, and then it basically allow you to read. I didn't put read the data here. Oh yeah, sorry, forgot about this. So you might want to read the data first, which is basically down here. This is the read data. So you need to call the read data. I left that out actually. You should read the data first here. And then if user want to enable or change the access point mode, you can provide that option. Okay, but I forgot to add that, just to call that function read data inside here. Okay, this is somewhere inside here, down here. So you just call this function down here. Is it? The function is at the bottom. Oh, the function is on the second file down here. So just call this read data. Okay, and then should be able good to go. So some inside here, we just put if you're unable to connect to internet through test Wi-Fi, and then you can just read data first. Okay, here, read the data first. Okay, so call the read data, which means allow you to get the current SSD from your memory, and also password for the SSID from the memory. So it start with test the Wi-Fi. Are you able to connect to the Wi-Fi? If you are able, launch the web. If you are unable to connect to the Wi-Fi, create the access point mode, and then create the AP mode and allow user to access the web server for configuration, which is the web type 1 here. So that's why I'm doing the web type 1. So you are able to access this form if you are unable to connect to the Wi-Fi. If you are able to connect to the Wi-Fi, it basically will provide you with this Wi-Fi 0 here. All right. So it will provide you with this form if you are unable to connect to Wi-Fi. If you are able to connect to Wi-Fi, it will let you know, welcome to Noon MCU. This is the IP address that is supposed to be able to access. Okay, so this is just to allow for your device to read the SSID from the memory, and then try to connect to the Wi-Fi first. If you are unable to connect to the Wi-Fi, and then return back to the access point mode, enable the access point mode, and then ask user to enter new Wi-Fi configuration. For example, if you're in UUM, you can just use the UM Wi-Fi guest. But if you go back to your home or to your college, you don't have UM Wi-Fi guest, we'll try to connect first, and if fail, it will automatically enable the access point mode and ask you to enter new configuration without having to compile your code again. That's what this thing do. Okay, this code do for your system. Okay, so it basically provide that service. So because as a user, definitely I have no idea how to compile the code. So this allow for user to access the configuration, change the SSID, and definitely people they are familiar with the form, and they can just enter the SSID or whatever instruction that you have, you can just put at the top there. Okay. All right. So I think that cover EEPROM. So let's see some simple example. Oh, but I believe this one is the same example that I already provided up there. To turn on LED and LED off. Okay, basically the same thing. Okay, this is just to display back the status of the page. I've shown you that in your previous class already. So this is just sample example, and even you can create a button, an on and off button. If you see this IP address, means that this is automatically AP mode. Automatically, this is an IP address for access point mode. But if you see the IP address as local IP address, means that is in a Wi-Fi mode. It means that your ESP connected to a Wi-Fi access point. So 4.1 AP mode means that you have direct access to the ESP. Okay. Unfortunately, I cannot show that anymore. The second method that in UM, so they block that already. So this is also the same LED on and off, but in Wi-Fi SSID mode. This is the Wi-Fi mode. The same thing for Wi-Fi mode. All right. So 3.4.3. This is actually if you want to develop an Android application. But I believe this is an old example that I have from my Android day, the Android Studio day, because I no longer use Android Studio for developing IoT application. Mostly nowadays, I just use Flutter, which is very, very fast for me to develop any type of mobile application for Android, for iOS. But this is an example for Android Java code that I used back in the day. But they are basically the same. If you're familiar with mobile application development, but I'm not quite sure how familiar are you with Android development. Anyone? Do you have any experience with developing mobile application? But you do have mobile web application development subject, right? Who is the lecturer? Dr. Suki. Ida. So they use web framework only. Can you compile to iOS, to Android? Any? Okay, that is really unfortunate. Really, really unfortunate, because I've talked about this many. I need to recording this one. Okay, so for the idea here is that we want to be able to read the data. Okay, that's what we have been doing so far. We know how to do this already. Now we need to be able to. We can connect now to the router, so which is UUM router. So which basically allow us to connect to the internet. Okay, So that is now the capability that we are opening up. So we are here already, so we can do this already. So this is basically done in our class. But now we need to be able to push the data, so this temperature and humidity data here, to the database. Okay, so the database decision here depend on your application. If you want to have a real-time database, okay, a real-time database, RT. On already. So if you want to have like real-time database, which you need to select a different type of database than conventional. So the other one is conventional. Okay, so conventional database means that this is a relational type database. Relational type database. For real-time database, usually you have multiple options. One, you can use MQTT type protocol. Okay, but this will require us to change a few things here to be able to use MQTT. It is recommended to use MQTT, but for now, let us not use that yet, because this will require us to change our transport protocol here. So our transport protocol here is based on HTTP. So HTTP, they have functions to request. Okay, so to request the server, either you can use get array or post array. But for this device, we use get array because get array is easy to use. We pass through URL. So all the data is in the URL. Okay, easy path. For post array, a little bit difficult because we need to put it into body. Okay, so we're going to focus on HTTP request for now. But if you want to use real time, there are other options available. You can use Firebase. You can use Firebase database, but this one from the mighty Google. You can use AWS. Another option here, AWS database. Okay, but I'm not familiar with AWS because AWS nowadays require payment to be able to use their service. So they provide free for like say like $100. Once $100 run out, you have to pay. But for Firebase, it seems they still allow for free tier. But unless you start to publish the application and you have high traffic, then you start to pay. So they are still free for now. AWS, they already implemented payment paygate. Firebase, Google, they allow free tier, but once you exceed the free tier, then you have to pay. So that's why it is better to use Firebase compared to AWS. AWS from Amazon Web Service. Okay, but Firebase, they have one special feature called real-time Firebase. Okay, so which allow you to store data in real time, near real time, not real time, near real time. Okay, so which is you can store a lot of data. You can update your database, read and write to the database very fast through JSON data. It is actually just a JSON data. Okay, so AWS also use the same JSON data, but again, the issue with payment, paygate. So you have to pay to be able to use their service. Nowadays, everybody asking for that money. Everybody want money. So even though Amazon is a big company, they also want money a lot compared to Google. They're still not that what do you call it? Yeah. But they're moving towards that. I noticed that. Okay. Google, right? So we'll try this first. Because if you want to use the relational database, that will require a web hosting. I do have web hosting, but I'm going to show this later. We need to build our backend service. We need to build our database for example, like MySQL database. So this is just a very conventional database, which we can just communicate with the database. But we cannot do real-time database in conventional database. No, you cannot do that. Okay, you can store data a lot in your SQL database, but SQL database, they do have limit. If you dump all the data in real time, the HTTP requests also, they have limit in terms of the protocol. So you have to understand the limitation of using conventional database compared to real-time database, which allow you to just dump the data very, very fast, write the data into JSON data, or even update data. But JSON data, usually you don't update them much unless you want to, because update costs a lot of, there's a cost in updating the data. You can dump the data very, very fast, but to update the data, how they call it, update the document, that will take a number of requests. Okay, and that request basically counted in the pay gate. So you have to understand this is a paid service. They provide free tier for development, but end up later, if you are not familiar with the request, they will cost you a lot of money. Okay, for this. This one is relatively cheap, but you have to get your own web hosting. Okay, you can share with your friend if you want to. Ada yang ada web hosting tak? Your own web hosting. Anyone? No. You need one. Okay, you need to learn how to use or how to push your project to web hosting. Okay, so I would suggest for you to use or to buy one or share with your friend. The cost can be the one that I use 5 gig of storage with unlimited database, 100 gigs of bandwidth monthly, and with email configuration and everything. With domain name is about 140 ringgit per year. Per year. No, per year. All right, so 140 ringgit per year, you can share like 3 or 4 of you. Okay, so you can cut down the cost. So share with your friend, but you have to trust your friend. If your friend deleted your file, so that can be too bad. So get one. Okay, it's good for you to learn how to manage your own server, how to create your own domain, subdomain, how to manage web email server, how to push your project to your web hosting, how to publish your project. Okay, so you develop your backend and everything, and then you can just push to your to the web hosting, and then you can taste the experience of how live application works. Okay, it's very important to be able to do that. And again, this is just another investment that you might need to put forward. All right, so we're going to look into this first, how to do this, how to implement Firebase and connect to the Firebase database. So we're going to work on this for now to redo the temperature and humidity project, and then connect to UMY Firebase, and then we need to create what we call as a Google console Firebase database with the Google account. So you need Google account here. The reference you can use, I do have one here, but this one is HTTP request. So you're going to do this later. This is the one that typical requests. Okay, so if you can look here, node MCU get request to a PHP document somewhere over the server, and then PHP document will query the database and return back the query and return back the result to node MCU to ESP. So these are very typical GET requests through the use of HTTP GET requests. The other method that I use, I'm going to do that later. We can do this later. This is a typical database, the one that I mentioned before. Python extraction, database connector to analyze. Okay, this is the one that I mentioned about the MQTT broker or the MQTT protocol. There's another protocol that usually being used in IoT, but I don't use this much because it is quite expensive. Okay, because you need to subscribe to MQTT server. MQTT server, they are basically HTTP server, but they are different in the protocol that they use. They use MQTT, they don't use HTTP. So if you want to communicate to the MQTT broker, the protocol that you use is MQTT // and then the domain name. So they have different transport protocol compared to HTTP. Okay, so let me check first if they're still available nowadays. They are free version, but free version, they are best effort. So there are Adafruit, there's IO Adafruit library, if we can still use them. Maybe we can still use them. Okay, I hope so. It has been a while since my last visit to MQTT. I'm not quite sure if this can still works or not. But you can see the configuration will take a little bit effort there, but still can be used. I believe this is my old code. I might need to look around because this is an image actually. I cannot edit this. So I might need to write them back. I'm not quite sure where the code already, maybe somewhere in my Git repo, might need to look for that. Okay, they call it PubSub. Okay, publish and subscribe. Okay, I'm not quite sure if I have the, because I'm looking for the Firebase example. Where is it that I put them? Another mobile application. So again, another mobile apps. Okay, this one I use MQTT library. This is a MQTT library. Okay, I don't have that for the Firebase. So which means that I need to pull from the trusty random tutorial. Okay, so I do have one example here, but I believe Firebase already updated a few things with the authentication for the Firebase. But let's see if you are able to use this tutorial for our example. All right, so this is basically with Firebase, okay, Google Firebase. So ESP8226 or Node MCU, sometimes I call it Node MCU, sometimes I call with the full name here. But for the development board, usually I call it Node MCU. So what we want to do here is that this. Okay, so this is basically the design that we're looking at. So you have your ESP here, and then you can connect to a Firebase database, store the data inside here. And you can use another node, either application or another node MCU to be able to read the data from database. Okay, store and read, store and read. The good thing about Firebase is that you don't have to build the back end. There's no back end to build, only configuration that you have to provide. For example, like the API key, the library that you need to import. But the good thing is that there's no server-side script at all. You don't have to build a Flask application. You don't have to build PHP application. You don't have to build Node.js application. For the server-side script, none of that. Okay, it basically cut your time short with Firebase. It seems to be good, but one problem is that you are at the mercy of Google. Okay, so when suddenly Google decided, okay, you have to pay now, so you have to pay at their mercy. Okay, so seems to be working for now. For prototype project, seems to be good enough. But in reality, if you want to fully realize your application later on, that you have to put into consideration. It won't last forever. use it while it's still good. And then if something goes down in the future, so you have to understand that it's a free stuff. You want to use it, pay for it. There's no free stuff in this world. Okay, understand that. Okay, so now the step that you need to follow is very simple. To set up a Firebase account, you need a Google account, and then go to your Firebase account. I have one thing that maybe I can just promote for you. There's a Firebase Google. I believe a Google developer. There's a Firebase IO, Google IO coming 14. So you can register now. It's free. It's online. And then when the time comes, you can just join them. Okay, Google IO. It's a very important event for any most of Google product. Even Flutter also come from Google. So join them for anything new, right? So now you can go to console. If you haven't yet registered, you can go to console for registration. But I'm Google dengar apa saya cakap. Android dengar. All right. So I'm not quite sure about the new registration because I've heard before through Tech Talk that you have to pay. I'm not quite sure about that, but this is the old one. I have old account for last like 15 years account. So my account is good. I can log in, I can access my account without any issue. But I'm not quite sure about new account. If anyone can try to access your Google Console account, you can go to the Node MCU for the link for this random node tutorial ESP82 for Firebase. Go to this link, Firebase, and sign in your Google account. Let's see if you're able to access that link. This is my account, and I can go straight to the account. I've heard rumors that you have to provide debit account. No, tak perlu. Anyone? Do you have any experience? Because I've heard that before. For new account, you have to pay. Okay now. All right, good. So it seems it's still working now. Should be no problem for you to use this to create account or developer account with Firebase or even with Google Console. Okay, so once you have that, so you can just create new project, add project, and then because I already have my project created here, so you can follow the tutorial how to create project, give a project name, and then enable Google Analytics if you want to. But this one basically disable because this is also paid version. If some of these you need to pay for the function, so maybe that's the reason you disable Google Analytics. And then you have to wait for a while for the project to be created. And then once you are ready, you should be able to see your dashboard. Okay. So once you have this, so it seems to still be free in this mode yet. Okay, so this is basically, yeah, up here. There's a Spark plan. So Spark still free for now. So $0 per month, limited access. You can use, there's a quota on the database, Firestore database, real-time database. There's a storage, authentication, and also static hosting. Only static hosting. For pay as you go, there's only two plans only nowadays. Blaze plan, which is pay as you go based on the project. It will auto calculate based on the usage of the project. Okay, so which is quite okay. So the plan basically allow you to do what? A/B testing. You can perform A/B testing, analytics at no cost if you want to. App check, no problem. Distribution also no cost. Authentication, okay, so only 10 SMS free per day if you want to use phone authentication, for example, like OTP through phone. Other type of authentication, email authentication, identity platform, active user, the maximum active user, which is generous enough, I believe 50K user that you can have a lot already, because if you have 50K user means that you already make money. If you don't have 50K user means that you don't make money yet. But even with 50K user, you can already make money. Okay. Monthly active user, but I'm not quite sure what is SSML or IDC, 50 per month, but I'm not quite sure what is this. For database, Cloud Firestore, 1 gig total, which is okay for text data, because this is mostly stored in Cloud Firestore is JSON data. So for JSON data, 1 gig is very, very big. Okay. Network address 10 gig. Document. Okay, this is important. There's a document write and document read. For IoT, if you have real time, you're going to have a lot of document write and read, reading and writing data. So every time your ESP read and write data, it will be counted as one API call. Okay. So if you have real time, so 1 minute, how many seconds? 1 hour, how many seconds? 1 day, how many seconds? How many cycle that you implement this? So you can total up that for one device. Okay. So read and write. Even deletes also counted here. Read, write, and deletes. So that's basically the maximum cost per day. But I think that's more than enough also for per day. Okay. So means that they haven't yet changed this. Seems to be okay. Cloud function not available. CPU outbound, you don't have to. It's not free here. Cloud messaging. This is if you want to use what do you call it? Notification, cloud notification for your application, so you can use them at no cost, which is surprisingly free for this. So if you want to have like these features, you can implement it at no cost. Cloud storage. This is all the data that provided for you. Even machine learning for AI people, if you want to implement Firebase ML, so it's free there. There's a model free. But if you want to use any of their Cloud Vision API, it's not available. So you have to pay for per thousand, $1.50 per thousand. For any Cloud Vision API, any AI services that you want. For custom model, your own custom model you can develop using Firebase ML is free. So quite a lot of things provided for you. Gemini, free, but this is under public preview. You can use them for free until May 11. May 11? Habis dah? Is it May? Oh, still lagi. Okay, but yeah, not much. Okay, so that's basically the plan that you can, or even you can customize whatever that you want here. So many things you could do. Okay, so yeah, there's good things to for Firebase. They still open up developer purview. AWS no longer allow you to do that. They provide you $100 for free, but after $100 gone, you have to pay. Okay, that's how they work. That's how their pay gate works, right? All right. So now to create a project, so you can just follow the tutorial available here. So once you have that, you need to set these authentication methods for your application. So the authentication method you can select from this menu over there to the left there. So authentication methods. For development purposes, your sign-in method you can set to anonymous. So it means that you can allow everyone to access, to gain access to the service, to the database. So please enable that. But in development, when you want to publish any Firebase project, you might want to consider any of the provider here. For example, email and password, or even if you want a single sign-on, so you can enable through single sign-on services through OpenID. Oh, this is the SML. Okay, I'm not quite sure what it is, the SML services. This is basically related to our identification ID. Okay, so SAML. Okay, so you can use this, but for development purposes, you can choose anonymous. Anonymous allow you to allow anyone to use the service without authentication. Okay, so we basically telling disable the authentication for now. Okay, we don't want the authentication because authentication added another layer of complexity to the project. So to make things easier, disable the authentication. No need for the authentication for now. All right, so that's one thing that you have to look into, authentication mode. Okay, so set authentication, disable everything, enable anonymous only. Okay. All right, so then you need to create a database itself. So here, for the database, there are two types of database here. One is a Firestore database, the other one is a real-time database. For IoT, choose the real-time database. Okay, IoT, you need to choose the real-time database. Don't use the Firestore database. Firestore database, this is for application development, for Android mobile application, for web application. You can use Firestore because Firestore, they provide some level of query. Okay, you can have complex query, which is usually not available in what we call as non-SQL type database. Okay, so if you understand about non-SQL and SQL type database, SQL is the one, is a relational database, which you can use SQL statement, but Firestore database is non-SQL database. No, Oracle masih lagi SQL, ada lagi SQL. Oracle database still run all. When we talk about non-SQL database, we are referring to database that they don't have structure. They don't have a data type. They don't have relational data. So it means that you can do relational data between two object, two class. There's no relation between them. Okay, so, but they are very fast. They are very scalable. And then the only downside is that there's no relationship. You cannot perform SQL query like in the traditional database, in conventional database. Okay, but Firestore, they are basically that non-SQL database, but they have features like relational database, some sort like features, but not full-fledged features. Okay, so Firestore. So if you want to develop a web application, mobile application with Firestore, you can use Firestore database to store your database, but in non-relational database. So you have to learn about non-relational database development. And then nowadays it's very popular. Even even all the Facebook, TikTok, all these highly scalable application, they use non-relational database. They are no longer depend on relational database. Reason being is that relational database very limited in terms of performance. You can only scale up to a certain level, but if you reach at the level of Facebook, of TikTok, of any large application, large user base application, you cannot use a relational database anymore. Okay, you have to move to non-relational database because they are very, 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 very fast to access. Okay, and then they are non-structural. You don't have to worry about data type anymore. Okay, you just use key and value, key and value, key and value, and you can group them together. You can have like this data, they don't have this entry. The other data, they do have entry. So they don't have any structure at all. They just use JSON structure in that sense. The database is being arranged in JSON data type, JSON data structure, sorry. Okay, so just access your real-time database, and this is basically your URL up here, your database URL. HTTPS my IoT project, and this is for mine. But you have to select the location of the database. There are 3, I believe: Singapore, US, and somewhere in Europe. So you have to choose which one that you want. The one that I choose is in Singapore, closest to us. Okay, so this is the database in the
in Singapore, Google server. I'm not quite sure why they put it there, because when we talk about server, the heat that it produces is very high, and the electricity that it needed to cool down everything can be very, very high to maintain. So I'm not quite sure in Singapore. Singapore, like, they sit on top of Katu Istiwa. It's very, very hot there also, much hotter than us, because they sit right in the middle. So, but they still have server there. And maybe they have a lot of rebate on electricity. But that's how things work. Okay, if you have like a lot of rebate in terms of the technology when you put it into the country, so people will come. Okay, but yeah. So this is the server, and as you can see, I've created a simple structure here. This is a very simple structure. Okay, so 100 means that this is my device ID, and this is the data that I want to store. This is key, this is value. This is key, this is value. This is object. Okay, this is the object. So if I reach out to this, as you can see, the URL to this is in this format here, /100/temp. Okay, means that I want to access temperature data. So I can go back to the database. This is my database name, .app. Okay, so this the name of my database is this is the full URL. My database name is this one. Okay, this is the ID of my database. All right, so how do we use them in our database? So you can just easily create them. Like if you want to add more, so let's say key value, you want to add, sorry, this is a key value. You want to add more data. Let me just delete them first. Let me just show you how I created the data. So clear everything, no data in the database. So I want to create the first tier data structure here. You can use random data, but here I just want to use a very unique key here. So let's say the device ID that I have is 101. So I need to configure in my device here, in this here, the device ID. So I know that for other ID, 102, 103, 105, whatever ID that you have, it has to be unique. Okay, you can set them yourself. All right. So once you have that, so if you want to make this as an object, so you can just create is it here or here? I think here. Yeah. Plus that, and then you can start to have your data. So I want to store, the first one is DHT. So let's just put some value there. So DHT like 70%. And then I want to add one more data, which is temperature, which is 27 degrees Celsius. And press enter. All right, done. I have my data here already. Okay, but the idea is that I want to be able to update the data based on the data that I receive from this sensor. Okay, all right. So this is the ID. This is the data for DHT. This is the data for not this. This one should be not DHT. I'm going to change the name. Should be I'm going to delete this. This is humidity. It's supposed to be humidity, right? So I'm going to add one more. Humidity. All right. So it's supposed to be like 70% humid. So humidity and temperature. So those two data, not DHT data. DHT is the sensor name. All right. So, sorry, not this one. So let's see the next thing here. So this is the server that you want to use. Security, for now, you can set them as a test mode. So for development, means that everybody with the link can access the data, can read and write the data. But once you are ready to publish the application, you might want to change this to a log mode, but you have to provide authentication, okay, through email and password. So that's why you can create another EEPROM inside your ESP to store the authentication data. Okay, you can store the authentication data inside there. But for now, when you set up new database, set up in test mode. Okay, so you should be able to get your database name there, and then you can start filling in data inside. Next, you need to get a project key. To be able to access to the database, you need a key, API key. It's just a normal things to do. To get the API key, you have to go to the project overview, go to the project setting here, and you can go to the web API key, this key here. Yeah, web API key, right? Yeah, the web API key. So you need to store this somewhere, put it into the notepad or whatnot, right? So you can just store somewhere through your notepad, a sticky note or whatever. Okay, so this is your web key. And then you need to take this random node. Now they already changed to platform IO. I haven't yet changed to platform IO because I like using Arduino IDE. But everybody now moving to Visual Studio Code with platform IO. I've tried that before, but it seems too many things inside the platform IO. So I go back to Android Studio to Arduino IDE, which is much more familiar to me. But if you want to use platform IO, you can use platform IO. They call it PIO. In the Visual Studio Code, you can install the library, the plugin, and everything, and then you should be able to write your Arduino code in here. An example that provided here through platform IO. But still in the Arduino IDE, you can just import the following library, right? So you can access your. You can create new project. This one I already take the code, put it into the code that I have from here. A little bit modification here and there, but it's all the same. Okay. So the library that you need, the first thing is that you need Firebase ESP client. So Firebase ESP client. So get this version. Okay. So I already have them installed in my Arduino IDE. The library by Mobits. Okay, the current version that I installed is the latest version, but I'm not quite sure if the latest version is okay or not. But use the one that already compiled by Mobis. The other two versions also by Mobis also, but if you just want to focus on ESP32, but this one is he already combined this, but I'm not quite sure he or she Mobis because it's just the name of developer. So by Mobis. All right, so I just installed the one that already pre-compiled with two microcontroller. And the other one that you need to install library is Firebase Arduino. Done with that is Firebase helper. Let's see the Firebase helper. This one here. But this one they didn't talk about that. Is it? Yeah, this one. But you need to install the library for it. But it didn't tell you to install the library. Where is it? The library. I don't think so. They have the library there. But never mind. Let's just try to compile them first. Okay. So the code that I've taken from here with modification a little bit. Okay. So you need ESP8265 Wi-Fi. So there's a library on DHT. So this is the one that I use a lot. And then this is the one that we just installed called Firebase ESP client. And there are two other requirements. Before this, there's no need for this. I've tried this before. But nowadays, they need this token helper and this real-time database helper. So they basically shorten the database request through these two header file, this helper file. And then define the sensor pinout. So I use D4, pinout D4. Create an object. Define UM Wi-Fi guest because I wanted to be able to connect to UM Wi-Fi guest. And this is just a normal Wi-Fi connectivity. The API key, now I need to put the API key and database URL. So there are two things that you need to put here. One is the API key. And the other one is the database URL. So I'm going to take the database URL. Where is it? Real-time database. And copy the database. Okay, so copy the database and put it into the link here. So that's basically my database. Okay. Don't forget the key and database. This is to test the signing. Okay. So this is since the Firebase we set up with anonymous, it will basically try to configure with nothing here. Anonymous. Okay, so the Firebase sign up allow us to try the key, the configuration key that we have here, and with the database URL and the authentication method that we try here, which is we pass nothing. Okay, we didn't pass anything. Means that anonymous, right? So if everything okay, sign up okay. So set the flag to true. So if the flag is true, if anything goes wrong, print out error. And here just to prepare the callback and then listening to the Firebase connection. So the config token status here just to use all the token that we define up there. And then begin the transaction. And Firebase, there's a one tag here just to reconnect Wi-Fi to make sure that the Wi-Fi stay connected. And then we loop, but down here, I haven't yet passed the data. Okay, I just want to get first DHT, test the connectivity first. All right, so this is basically the code that I retrieved from here. But I haven't yet updated this section here just to check if my Firebase is ready. Yeah. Okay, so the same code actually, but for the random node tutorial, it used a random number. Okay, I can just also use the random number here. Okay, so if I wanted to, there are two data. One is a float, one is, all right, never mind. Let's try with this first. Okay, so I'm going to try to verify the code, if the code is okay or not, if something goes wrong with the library. So check the code first. And remember, when you want to push to your GitHub, please remove your key first. Don't publish your key in your GitHub repo. Okay, this is your key. Something goes wrong here, down here. Config authentication auth not declared. Send okay. Oh, okay. I forgot to the flag is not there. I think I removed the flag up here. Where's the flag? Full key. I want to check the flag first. There. Forgot to set up the flag. So we have the flag. What else? Authentication was not declared. So another one. Firebase config, Firebase this one, database object. I think I already declared them up there. No, I didn't have them. Right, so one more time. Let's try to compile them. So let's see if we're able to communicate with the database first. Okay, we are not yet save the data. We just want to test the authentication. We just want to test if everything is okay with our Firebase. Okay, seems to work up until here. And this should be okay. So we can test them now. Let's see. Yeah. So let's see if we can work with the code. Okay. Upload. Module not connected. Oh yeah, COM3. All right. Fortunately, still having issues with connection. Yeah, connection issues. So connected to COM3. So always check your COM. Okay. So if it's not connected, happen again now. It happened again. Hope so. Yeah. Okay, uploading. So cross your finger, make sure that it works with the current form. I might need to buy the magnetic USB. I think it's better to use magnetic because it's easier for me to take off and buy the better version. All right, 100%. Let's see serial monitor. Trying to connect. Okay, Wi-Fi connected. All right, so everything is okay now. Able to communicate with this server, but this one just to read temperature and humidity only. So I might need to connect to my DHT11. Make sure that I'm able to read the data from the DHT. Positive. This one is positive, negative. And data. Okay, positive is purple. Positive is purple, but I believe I need to take from Vin. Ground is ground, and it's better D4. Yeah. Yes. All right. So you can see the temperature and humidity is there. 27 degrees Celsius, 64% humidity. All right. So, but we haven't yet uploaded the data to the database. So as you can see here within the loop, there's only get DHT. I can get the temperature and humidity, but again, it's disconnect. My port is not very good. The cable is not very good here. So I would suggest if you're having issues with your USB cable, get the good version one. Okay, the one that I have here is very, very problematic. Yeah. Okay, so now all the connection is working. I'm able to connect to able to read the data, and then able to connect to Wi-Fi, able to connect to Google Firebase. But I haven't yet able to write the data to my Firebase database. Not yet, because my loop here just read DHT data. So that's why you can see my DHT data there within 1 second delay. So I'm going to update this with the code here. So how do I'm going to update this is through this if statement. So the if statement here, I'm going to take 1, 2. This one is the first data. That's integer. I'm going to take all this first, all the if statement, and then I'm going to change them. Okay. So within the loop here, so within the loop here, we're going to need send data melee. Send data melee. I don't have that, so that's basically for the timer. So need to get the timer and the count. So put it up here. Okay. So send data melee up there. All right. So if I want to write the data, I'm going to use this if statement. Okay. And then check for where I want to write. So here is to write integer number. So if I want to write an integer number into here, so my ID is 100 and the first data that I want to write is what data? Humidity. Okay, so humidity. So the humidity data, I'm going to need to be able to read the data first. This data here. I don't have humidity, I don't have temperature variable assigned to. Here I just read the data, not assigned to any variable. So I'm going to create variable first for integer humidity and temperature. Okay, so by default, I'm going to assign them to 0 and also to 0 for both of them. And then when I read the data, I'm going to assign them to a value. So humidity is equal DHT humidity, and temperature is equal temperature. Okay, so get the data first, humidity and temperature. I've defined them in up here, humidity and temperature as an integer data. I hope both of them are the integer data. So, and then try to get DHT first. So try to get DHT. So I'm going to loop them. But I have to be very careful in terms of the timer here. So the timer here, maybe I'm going to use like 5-second delay. So read DHT data and then wait for 5 seconds and then go back to the main loop here. Okay, so start with that. So I want to store the first data is humidity data. So for humidity data is hum. And this one just to print out path and data type. So there's no need for this. I just want to, hold on. Path, data type. Okay, just leave it there first. The second data that I want to store is temperature data. So basically the same one. So I'm going to take all these. I'm going to take the same as this. Then we show that why they put a count there. What is this count? Count is for what? Nothing. So I'm going to remove count. So the second data is for temperature. So 100 temperature. So this is for temperature data. So the rest is basically the same. Temperature and humidity. Check again. Temperature and humidity. And oh, this one is 101, not 100. So which means that I want to have like 101 for the database path. Right. So every 5 seconds, it will read the data and then publish the data. So I'm going to verify first, check if anything that I left out. Should be okay. Maybe I can put delay at the bottom of the loop, not inside DHT. We'll see. All right, seems everything to be okay, and I'm going to push this to the server to my ESP, and let's see if we manage to see any changes to the value here automatically. So shall we? Are we able to do that? Okay, still connected. Hopefully uploading. O1 and humidity and temperature. Which is basically the same. 101, right? True humidity and temperature. Yeah. Okay, so try to connect to Wi-Fi. Wi-Fi connected. Read data, temperature and humidity. Wait for 5 seconds. There you go. The value now changed. See? Let me try to change. I hope the humidity change. There you go. Temperature a little bit. So every 5 seconds, the data will be updated here. Okay, so we have managed to do this. Firebase. Okay, so there's no humidity now 95% because of my tube tadi. Okay, so it's very humid, 95%. Okay, so temperature is 27 degrees. Now the humidity is changed. If the data is not changed, they don't change the data. If it remains 27, there's no change to the data. But if something change here, it will change the data. Okay, so 5 second interval. So it means that every 5 seconds, it will be counted into your cost, into your overall cost, your Spark plan. That's why you have to be very careful when you develop using Firebase database. Okay, to be able to store the data here, even though it's free, be very careful. Okay, and if you please don't register your debit card or credit card with this, or you need to set limit. Otherwise, if someone use your key here, if you suddenly publish the key online, or you didn't delete the key, and someone used the key, and then they exited the key, the request, the API request, and then your credit card will be automatically deducted, or your debit card will be automatically deducted. So be very careful on that. Okay, jaga-jaga, right? Okay, and then you can develop mobile application, Flutter application to read Firebase to be able to display this on mobile app. Okay, so you can see one semester project, I can do it in one class. I've seen this type of project before with a final year student project. Was it? Macam ni je. Ini je awak buat. So yeah, that's the thing with me. Okay, so just a very simple one. So all the data here, configuration here, you can store this in EEPROM. Your Wi-Fi configuration inside EEPROM. Alza, I call it Alza key. I'm not quite sure. The names always start with Iza or Alza, Iza. So I always call it Iza key. But this is the web API key. And if you want to, maybe if you don't change these two, so you can just you don't have to put it into your EEPROM, but the data that you want to put into your EEPROM, definitely Wi-Fi and SSID, and also device ID. Okay, because the device ID change, you have multiple device ID, 101, 102, 103, 104, 105. So those are the data that change. So any change data, you might want to use EEPROM. If the data is not changed, then you can use as a static value inside your Arduino code, right? Very, very simple. You don't have to build anything, any back-end code, Flask, Node.js, PHP. Okay. So for your final, if you want to your final year project, if you're a little bit lazy, you can go for Firestore. Free. This is a free database. But you have to learn about NoSQL database. So you need to learn how to manage data, how to create data object with NoSQL database. Okay. So you don't have to think about backend anymore. You just think about your application and your database. That's it. There's no middleman there. The middleman already written for you. But tak ada cabaran lah. Saya tak suka sangat macam tu. Saya nakkan cabaran. Saya suka duduk kat tengah-tengah tu. Okay, so yeah. So nowadays a lot of things that you can use, or a lot of services that you can use. Okay, you're not limited to one thing only. So many things that you can do with this.